Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we will discuss about six-member ring containing one heteroatom. We have nitrogen, oxygen, sulfur, etc. are heteroatoms. So in previous lecture, we completed five-member ring containing one or more heteroatom and simple and fused compound. Now we have six-member heterocyclic compounds like pyridine, pyran, pyridiazine, pyrimidine, pyrazine, quinazoline and benzoxazine or phenoxazine. So today we start with pyridine. Six-member ring containing one heteroatom, that is pyridine. One heteroatom, one nitrogen heteroatom contains pyridine. Pyridine and methylpyridine was discovered by Anderson in 1849 from boyne oil. First of all, pyridine and methylpyridines were discovered by Anderson in 1849 from boyne oil. We have some important synthetic method for synthesis of pyridine and some of its derivative is also important. So today we will see about pyridine. Now we draw the structure of pyridine. Pyridine is six-member ring heterocyclic and heteroatom is in pyridine is nitrogen. So six-member ring containing one nitroatom as heteroatom is known as pyridine. This is pyridine. Now we see some synthesis or preparation of pyridine. First of all, we see first preparation from acetylene and hydrogen cyanide. Acetylene, 2 moles of acetylene, CH3 triple bond, CH triple bond CH, and hydrogen cyanide, that is HCN, and this HCN is basically this compound is triple bond N. This is HCN. When this mixture acetylene and hydrogen cyanide are passing through a mixture of hydrogen cyanide and acetylene passing through a red hot tube. Cyclization takes place and it converts into pyridine. It is very important synthetic route by passing a mixture of acetylene and hydrogen cyanide through a red hot tube, we get pyridine. Second method is from aldehydes or ketones and ammonia. Interaction between aldehydes and ketone carbonyl group. So we here synthesize pyridine by ethanaldehyde and ammonia. Aldehyde and ketone on reaction with ammonia. Aldehyde and ketone with ammonia under suitable conditions such as high temperature and under pressure gives pyridine. So ethanaldehyde CH3CHO 4 moles of ethanaldehyde and ammonia at 200 degrees Celsius temperature, it converts into 2-methyl 5-ethyl pyridine. And mixture of 2-methyl pyridine. This is 2-methyl 5-ethyl pyridine. This is 2-methyl pyridine. Ammonia. Ethanaldehyde. So interaction between aldehyde or ketone and ammonia gives derivatives of pyridine. This is very important synthesis. We have more synthesis, so we will see it. We see third preparation, pentamethylene diamine. Third preparation, pentamethylene diamine. This is pentamethylene diamine. When treated with ammonia, it converts into pentamethylene diamine and removal of H2O gives pyridine. Removal of H2O gives pyridine. Sorry, we have mistake. This is not pentamethylene diamine, but this compound is glutaconic aldehyde. Glutaconic aldehyde and ammonia treated each other. Removal of 2 hydrogen. removal of two water molecules, sorry, not hydrogen, it convert into pyridine. Now we see our fourth preparation from pentamethylene diamine. Pentamethylene diamine. So I write down pentamethylene diamine here. In this structure we have only some changes. So it convert into pentamethylene diamine. Number 4 preparation. Number 4 pentamethylene diamine. CH2 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 NH2. This is CH2 CH2 NH2. This is pentamethylene diamine. It is treated with 2 moles of HCl. Removal of ammonium chloride. First of all, it is transferred into piperidine. This is piperidine, and loss of H2 molecules at 300 degrees Celsius with the help of sulfuric acid. It converts into pyridine. It converts into pyridine. So this is very important synthesis from pentamethylene diamine. Pentamethylene diamine. We have one more synthesis of pyridine from furan. So we see number 5, furan derivatives. I write down 2-furyl ketone, derivative of furan. Furan is 5-member ring, 1 heteroatom oxygen containing heterocyclic compound, and this is furyl ketones. 2-furyl ketone. This 2-furyl ketone gives 3-hydroxy-2-alkyl pyridine when heated with ammonia. It is heated with ammonia, then it gives this is alkyl group and this is hydroxyl group. So we get 3-hydroxy. Second position is composed with alkyl group. So 2-alkyl pyridine. With the help of furyl derivative, 2-furyl ketone gives 3-hydroxy-2-alkyl pyridine when heated with ammonia. So these are the very important synthesis of pyridine. Now we see properties of pyridine. First of all, we see physical properties and then we see its chemical structure and chemical property. So, first of all, we see physical properties. Pyridine is hydroscopic, hydroscopic and colorless liquid. Colorless liquid. It is liquid, so its boiling point is 115 degrees Celsius, 115 degrees Celsius, with an unpleasant smell. It is unpleasant smell. It is miscible with water as well as with organic solvents. Organic solvent. So this is very important property, physical property of pyridine. Pyridine is a hydroscopic colorless liquid, boiling point 115 degrees Celsius with an unpleasant smell. It is miscible with water as well as organic solvents. Some basic properties we also discuss here. So, pyridine behave like a tertiary base and hence it forms salt with organic acids. Salt with organic acid. As for example, we see here one example for inorganic acids. So, pyridine is treated with hydrochloric acid and methyl iodide. So, its inorganic acid salt is formed. As for example, we have a structure here, our structure is right down here. This is pyridine. So, when it is treated with methyl iodide, CH3I, and we treated with HCl, then salt of inorganic acid produce. Plus this is pyridium hydrochloride. Pyridium. Pyridium hydrochloride, and this is pyridium methyl iodide. Pyridium methyl iodide. The basic character of pyridine is due to the presence of a lone pair of electron on nitrogen atom, which can protonate with the mineral acids. It is very interesting to note that the nitrogen atom of pyridine, even carrying a lone pair of electrons for protonation, is less basic than the alkylamine and also piperidine. One possible explanation for this is that as the nitrogen atom in pyridine is sp2 hybridization, that is, it has more character. It is more electron attracting than sp3 hybridized nitrogen. So, the basic character of pyridine is due to presence of a lone pair of electron on nitrogen atom. We see chemical properties for pyridine. Electrophilic substitution reaction. The resonance hybrid of pyridine shows that its carbon atom have lesser electron density than the carbon atom of benzene. It is very important point. Resonance hybrid of pyridine shows that its carbon atom have lesser electron density than carbon atoms of benzene. Pyridine and its derivative also differ from pyrrole in regard to electrophilic substitution reactions. The reason being that pyridine contains a double bonded nitrogen atom which attracts electrons from the ring, the reason why substitution reaction is differ from pyrrole because of the pyridine contains a double bonded nitrogen atom which attract electron from the ring, while the nitrogen atom of pyrrole donate electrons to the ring. This difference make pyrrole is differ from pyridine. Pyridine is much lesser reactive than benzene towards electrophilic reagents and corresponding more reactive toward nucleophilic reagents. Sulfonation nitration occurs at only at absent 300 degrees Celsius at position 3 only and or position 5. It is very important point. Sulfonation and nitration. Sulfonation and nitration occurs only at about 300 degrees Celsius and at position 3 and or 5. 3 and or 5. Here we see chemical example, properties for chemical example of pyridine. We see nitrating mixture. We see first of all nitration. So nitrating mixture of nitric acid and sulfuric acid at 300 degrees Celsius, then 3-nitropyridine, only 5% conversion takes place. Only 5% conversion takes place. And if sulfonation takes place, then at 230 degrees Celsius, in presence of HgSO4, then pyridine 3-sulfonic acid, 70% conversion takes place. 70% conversion takes place. So these are the sulfonation and nitration at position 3. We see here at position 3. Now we see more reaction for pyridine. Pyridine undergone by halogenation. Bromination takes place. Bromination takes place at 230 degrees Celsius to 300 degrees Celsius. Then we get mixture of mixture of 3-bromopyridine and mixture of 3 and 5. This is 3 and 5 dibromopyridine. This is only 3-bromopyridine. So, when bromination takes place at 230 to 300 degrees Celsius, and if this reaction takes place at 500 degrees Celsius, bromination takes place at 500 degrees Celsius, we get different results. We get mixture of 2-bromopyridine and mix with 2 and 5-bromopyridine. This is 2 and 5-bromo. This is Br. This is 2,5-dibromopyridine, and this is only 2-bromopyridine. So the temperature plays more important role in this formulation. In this last case, that is at 500 degrees Celsius temperature, the formation of alpha product is probably due to the fact that the reaction occurs by a free radical mechanism, and hence the active agent is bromine radical but not bromide ion. So, radical formed by the deassociation of the bromine molecules. Sometimes aluminium chloride and other Lewis acid catalysts coordinate with pair of electron of nitrogen. That is Fiedel-Crafts reaction, alkylation or acylation, fails with pyridine. As for example, pyridine is treated with AlCl3, aluminium trichloride. So it is fail. Node position enters at 2 or 5. But when pyridine may be mercurated, I write down here, mercurated with the help of mercury acetic anhydride, OAC twice, HgOAC twice, then 3 position is easily mercurated. At position number 3 is mercurated. HgOAC, mercury acetyl compound is produced. So these are very important chemical properties of the pyridine. Now we see, if we treated with NaNH2 and H2O, Na, NH2 and H2O, sodium amine NaNH2 and H2O, then we get 2 amino, this is NH2, 2 aminopyridine, 2 aminopyridine. Reduction takes place if pyridine undergone by reduction, pyridine undergone by reduction. I write down reduction of pyridine here. Reduction undergone by pyridine, then it converted into piperidine. Piperidine. And this is treated with 300 degrees Celsius with HI. Then it convert ring opening reaction of pyridine. This is normal pentane, N-pentane, and ammonia is produced. So, ring opening properties of pyridine. These are very important properties of pyridine. We have one more reaction with pyridine. I write down here. Here is some space. With the help of lithium butane C4H9Li. So, butyl group is introduced at position number 2, C4H9. C4H9. This is 2-butyl pyridine. 2-butyl pyridine. These are very important properties of pyridine. Some derivatives of pyridine also very important. Some of very important derivatives which are used for the medicinal application. So we here discuss about derivatives of pyridine. Derivatives of pyridine. Derivatives of pyridine. When alkyl pyridine occurs along with pyridine in coal tar and bone oil, there are 3 methyl pyridine: picoline, lutein, and 6 trimethoxypyridine. 2, 4, 6 trimethylpyridine. Alkyl pyridines have 3 different pyridines. This structure is not useful, so I rub out and we write alpha, beta, and gamma picoline. 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . one methyl group at position 2. This is 2 or alpha picoline. This is beta picoline. And this is gamma picoline. And oxidation takes place, then picolinic acid, nicotinic acid and isonicotinic acid are obtained. It is very important compound. Oxidation takes place. All three undergone by oxidation. Then alpha is converted into picolinic acid. This is nicotinic. And this is isonicotinic acid. These are three different compound of alkyl derivative, alkyl pyridines, and if there are one more methyl group is present in pyridine, this is 2 and 4, 2 and 4 dimethyl pyridine, 2,4 dimethyl pyridine. It is known as lutein. Very important compound drugs, lutein. And if 3 methyl group presents, 2, 4, 6 trimethyl pyridine, 2, 4, 6 trimethyl pyridine. It is known as collidine. So, picoline, alpha, beta and gamma, lutein and collidine are very important alkyl pyridine derivatives of pyridine. We one more compound which is today we discuss, that is piperidine. When pyridine is undergone by reduction, then it is convert into piperidine. So it is very important material. When it is treated with undergone by amide unit process, then it converted into, I have some space here, so write down a structure CONH2. It is known as nicotinamide. And it is very important vitamin B12 complex, compound of vitamin B12 complex. Nicotinamide. We have one more vitamin B6 complex compound of pyridine, and that is pyridoxine. Pyridoxine. I write down structure here. Pyridoxine. Number 2 position contain CH3, 4 position contain OH, 5 CH2OH, and 6 contains CH2OH. Sorry, 4 position. So this is pyroglizine, and it is vitamin B6 complex. B6, this is B6 compound. One more important is isoniazid. Isoniazid. I write down a structure of isoniazid, and it is very important. CONH2. CONH2. Isoniazid. INA. And we discuss industrial production of isoniazid in according to our syllabus in semester 4. So these are very important compound which are derived from pyridine. These are the derivatives of pyridine. Today we stop here. Thank you.